Alright, welcome back to the next part of my tutorial. We're going to tidy up this code a little bit and add in the last state before we put the model in. I think it's looking kind of messy and we need to just get things organized and start refactoring just a little bit. So the moving state here, we should be able to move into attacking as well. So the way that the sort of graph would work is that it'd be in idle state until the enemy is visible, at which case it moves towards it. But when it gets close enough, while it's moving towards it, when it gets close enough, it should enter attacking state. So we're going to tidy this moving up a little bit. The way we're going to do this is we're just going to look at how it's going to work. So I think the easiest thing to do would be to kind of like take away this, because if we can still see the player, we should be able to move into the a particular state, and then we can have an else statement for this if. So if we can see the player, then we need to do some logic. Otherwise, we can do basically what we did here. This is the else. Else will stop moving and move our state to idle. If we can see the player, what we want to do is we want to basically check to see if we can still see the player. Then we want to set the destination. So we'll copy that out, Control V, and then we want to check the distance. Now we used this statement up the top to calculate the distance, and this is going to be okay if we undo that. If we just uncomment this again so that we've got it back, because we calculate the distance every frame, and we're just going to say if the distance is less than some arbitrary value, like maybe, I don't know, 2. Again, we should not really hard code this, but we can just do this to test it. So if the distance is less than 2, and because we've already checked to see if we can see the player, we should be okay. So we should be in front. It should be in front of you and less than 2. Then we're going to move the AI state into attacking by typing in that AI state equals AI state dot attacking. So this moving now allows us to jump states to attacking or back to idle. So this is kind of like the middle state, and it can jump between the two. So now that we are in this attacking state, we don't really have anything to do in the attacking state other than probably stop moving. So again, just for speed, I'm going to copy this, and while we're attacking, we're just going to say that right now. Now, as these statements start getting larger, as these things start getting larger, it's probably a good idea to break them out into their very own functions. So this state is starting to get pretty big, as you can see, and so what we could probably do is to just break this out, refactor this a little bit, and make it its very own function. So I'm going to create a function. I'm going to make it a void return type, and I'm going to say we'll call this function onMoving. So onMoving, and we're going to take no parameters because we don't need any, but we're going to pretty much just do we need any? Yeah, we do. We need distance, because we calculate distance up here and we don't calculate it inside of moving. So we're going to say onMoving, and we're going to pass in distance, just like that, and then we can take this whole chunk of code up to the break. We can put it here. This is what we pass, so we need to use it inside the function. So the value that we pass to it, we use inside of here, and this will change the state and set the nav mesh agent, which is all good because they're all part of it. So you can see how immediately, because we call onMoving and we pass in distance, that this little chunk in here starts to look a lot neater, and we could do the same with each one of them so that we can get neater code. For now, we're going to leave it as it is and just check that this actually works before we jump into getting all the tidying up a bit more and getting the animations working as well. So I'll save the code, jump back to Unity, hit play, go to the scene view, and we should see the player stop. So he's in front, moves towards him, and he stops. If we click on enemy, we should see that his state has been changed to attacking. So this is where we would play the attack animations. And if I just check that it drops out, so we didn't write the code to drop out of attacking again, so we should get back into doing that. So when we're in the attacking, what we need to do is we need to check the distance probably, or check that we can do a combination of checking the distance and whether we can still see the player or not. So if we can't see the player, or if its distance is greater than a certain value, then we should go back to a different state. So we'll write it here, and then we can refactor it out. So when we're in attacking, we stop moving first up, and then we'll check the distance. So if the distance is greater than the attack distance, which was, I believe, 2. So if we go more than 2, then we are out of attack range. If we're out of attack range, what we should do is change the state to back to maybe moving again. If we change it to idle, what it'll do is it'll do one frame with where it checks the idle, and then if it gets through that and it ends up there, decides it is moving, it will jump straight back to that. So we might need to experiment with changing this to moving or idle. So while we're attacking, set the stop moving and check to see the distance is greater than 2. If the distance is greater than 2, then we go into a different state. Alright, let's just test that. The logic seems okay. This is probably the bad thing about not testing your code and doing it in one take. Right, here we go. So we move in front, starts to attack. If we move away, yeah, it goes back to moving again. So if I move far enough away, or if I get out of sight of the thing, it should end up stopping altogether. Alright, I think the video's long enough of 8 minutes. We could tidy this code up, but I'm going to leave it for now. We'll tidy it up in the next one, and we'll build in the spider right now, the animations. Alright, hope you're enjoying the series. Cheers.